time of flight counter measure nuclear charge, which is called Z, and energy. And then we have very, very precise silicon detectors, which measure charge and momentum, and the magnet determine the sign of the charge. We have a ring image Cherenkov counter, otherwise known as RICH, measure charge and energy, and at the bottom is an electromagnetic calorimeter, 648 kilogram, measure electron, positron, and gamma rays. Therefore, all the detectors measure energy and charge in a repetitive way. This is the transition radiation detector, identify electrons and reject protons. This is one of the extremely beautiful, elegant silicon tracker. There are 9 planes, 200,000 channels, and they have this measure sense to 1/10 of your hair. This is a ring image Cherenkov counter. It's very precisely made, has 11,000 photosensors, identify nuclei and energy. At the bottom is an electromagnetic calorimeter made out of 50,000 fibers sandwiched in 1,200 pounds of lead. So you can measure extremely high energy gamma rays and electrons and positrons. No other detector in space up to now has this radiation thickness of 17 radiation lengths. So this was AMS-02 when we arrived at Kennedy Space Center. So different from previous science on the space station, I will call this fundamental science on the space station. You can understand this very simply by realizing in space there are 2 types of cosmic rays. One type, light rays. Light rays has no charge, no mass. And in fact, all this beautiful work done at NASA, Kobe, Hubble, and done by European space agencies, Integral and Fermi, and many, many experiments, all measuring light rays. In fact, most of our understanding about cosmos up to now come from measuring of light rays. But besides the light rays, there are charged particles. Because it has charge, you must have a mass. And once you have a mass, then it's absorbed in Earth's atmosphere. So you have to go to space to measure the primary cosmic rays. And because it carries a charge, you need a magnet. Because only in a magnet, positive bends one way, negative bends another way. And so the simplest way to view this detector is light rays has been measured extensively. Many detectors. Charged particle for long duration, precision measurement to trillion electron volt is the first time. In other words, you open the door, enter into a new area. Some of the physics include the origin of dark matter. We know, and you certainly have heard, 90% of the matter in the universe is not observable. And because you cannot see it, that's why you call dark matter. Nobody knows what it is. So on the left side, you see a galaxy seen by a telescope, but that's only 10%. If you can see all the rest, a galaxy will look like on the right side. How do you detect dark matter? In space, we know there are cosmic rays, protons, electrons, helium.